Hey guys, today we're going to move on to section 1, topic 7, which is starting our polynomials piece. We're going to start off with talking about terms. So a term is a constant, variable, or multiplicative combination of the two. So if we look at 3x squared plus 2y minus 4z plus 5, all right, how many terms do you see? Okay, so terms is pieces. So how many pieces of this equation do you see? We have 4 different pieces or 4 terms. Those terms are, we have 3x squared, then we had 2y, then we had negative 4z, that sign comes with it, and then we had 5. So notice in between each term there was a plus or a minus sign that shows us that they're separated. Okay, this is an example of a polynomial expression. A polynomial can be one term or the sum of several terms. Okay, and there's many different types of polynomials. We're going to start off by naming them based off of how many terms they have. So if a monarchy has 1 leader, then how many terms do you think a monomial is going to have? It's going to have 1 term, like 3x or 4xz cubed y to the 12th. That is 1 term. That is a monomial. Okay. A bicycle has 2 wheels. How many terms do you think a binomial has? It's going to have 2 terms. And a triceratops has 3 horns. So how many terms do you think a trinomial is going to have? It's going to have 3 terms. All right, so we have a little chart we're going to fill. So type of polynomial, we have monomial, binomial, trinomial, and polynomial. So we just talked about how many terms they have. A monomial has 1 term. We used the example before, like 3x squared. Okay. A binomial, that's going to be 2 terms. Like an example of that could be 2y minus 7. It's 2 different pieces. A trinomial has 3 terms. Okay, the most common one you see here are quadratics. So x squared plus x, like minus 2. There's 3 different pieces. And then a polynomial is going to have 4 terms or more. So we only really have a special name if it's 1, 2, or 3 terms. 4 terms or more, we just stick with polynomial. So an example of that, you could have 5x minus 7y squared plus xy minus 1. So there's 4 different terms. So notice all of my terms are different. I didn't have something like 5x and then plus 2x. Because remember, those are like terms. That would actually combine to give me 7x. So those are not 2 separate terms. They are common. I would combine them. So my polynomials has different terms that cannot be combined. Something else we're going to look at are the degrees. The degree of monomial is the sum of the exponents of our variables. So if I had 3x squared y to the 6th, the degree here would be 2 plus 6, which is 8. The degree of a polynomial is the degree of the monomial with the highest degree. So we're looking for the piece with the highest degree. Sometimes you'll be asked to write polynomials also in standard form. And when you do that, you put the monomials in terms, the monomial terms in descending degree order. So you start with your highest degree and you work your way down. The leading term of a polynomial is the term with the highest exponent. Okay, if something is leading, it is first. So since our standard form has our highest exponent first, the first term is going to be our leading term. The leading coefficient is the coefficient of the leading term. So remember, a coefficient is a number attached to a variable. So it's going to be the very first number we have. All right, let's do some examples. Are the following expressions polynomials? If so, name the type and state the degree. If not, justify your reasoning. Okay, so some things you need to know about polynomials. Polynomials can only have exponents that are positive numbers. So that means you cannot have any negative exponents. Okay, so that's a big thing we got to watch out for. All right, part A, 8x squared y cubed. All right, I have an exponent of 2, exponent of 3. They are positive numbers. This is a polynomial. I don't see any plus or minus signs. This is a multiplicative of a constant and some variables. So this is a monomial. It's just one piece. The degree of this, since it's a monomial, I have to add my exponents together. So we're going to do 2 plus 3 of my exponents. So our degree is going to be 5. So a monomial with a degree of 5. Part B. All right, I have a 2a squared being divided by 3b. Okay, well, I need to get that 3b up, and doing our law of exponents, that's the same thing as saying 2/3 a squared b to the negative 1. Well, see, that's an issue. So if I can't have negative exponents, that means I also can't have variables that are going to be in the denominator of a fraction. Because remember, that came from having a negative exponent. So this is not a polynomial. Because we can't have variables in the denominator. Okay, because this is the same thing as having a negative exponent. All right. Part C, 3 over 2x to the 4th minus 5x cubed plus 9x to the 7th. All right, my exponents here are 4, 3, and 7. That's good. I don't have any variables in the denominator, so this is a polynomial. I see 3 different pieces, so this time it's a trinomial. The degree is going to be the piece, the term with the highest degree. So this degree is 4, this degree is 3, this degree is 7. So therefore our degree this time is 7. Part D, 10a to the 6th b squared plus 17ab cubed c minus 5a to the 7th. All right, lots of exponents, but they are all positive. And the ones that don't have exponents, like this a and this c, technically there is an exponent of 1 right there. So all positive numbers, no variables in any denominators. So this one is a polynomial. All right, there are 3 different pieces. So this one is also a trinomial. The degree So remember, I need to find the degree of each piece, and my highest degree is my degree overall. So the degree of this piece, I have to add my exponent. This is going to be 8. The degree of this, well, it's going to be 1 plus 3 plus 1, so it's 5. And this degree is 7. So the degree of the entire polynomial is going to be 8, because that was the highest degree for a term. All right, last example on this page. We have 2m plus 3n to the negative 1 power plus 8m squared n. All right, look right here. We have a negative exponent, and we cannot have that. So this time it's not a polynomial because we can't have negative exponents. Remember the rules you have to follow. You can't have negative exponents, and you also cannot have any variables in the denominator, because technically that is the same thing. Okay. Try it. So I want you to pause the video. I want you to go through and I want you to look at our examples here, A through E, and I want you to decide for yourself if it is or if it is not a polynomial. So go ahead and pause. All right, check your answers with mine. So for part A, it is a polynomial. I don't have any variables in the denominator, and the exponents that I do have are positive numbers. B doesn't have any variables, so that's fine. 34 is just a monomial. It's a constant. That is a polynomial. C had a variable in the denominator, so that is not a polynomial. D is good. Everything is positive. Remember, R and S technically have an exponent of 1. And E is not a polynomial because the very last exponent was a negative 1. All right, how'd you do? Did you do good? Let's try this one. Consider the polynomial 3x to the 4th minus 5x cubed plus 9x to the 7th. Okay, write the polynomial in standard form. Okay, remember back here, standard form was writing the polynomial by descending degree order, meaning starting with the highest exponent and work our way down. So the piece with the highest degree is going to be 9x to the 7th. Next, we'll have positive 3x to the 4th, and then we'll finish it with negative 5x cubed. So notice their signs come with them when we move them around. All right, what is the degree of the polynomial? All right, so the degree of the whole thing will be the piece with the highest degree. Well, we already know what that is because we made it move to the front. It's 9x to the 7th. So the degree of the whole thing is that high exponent, which is 7. How many terms are there? We have 3 different terms, all being separated by a plus or a minus sign. Our leading term is our first term, which was 9x to the 7th, which makes my leading coefficient the very first number, which is 9. Okay, guys, you know what time it is. It's time to beat the test. Here we go. Match the polynomial in the left column with its descriptive feature in the right column. All right, so we have A through G over here, different polynomials to look at. They are all polynomials. And then we have 1 through 7 on the other side to be a key feature to match it with one of the other ones, okay? So I'm actually going to start from the right side. I'm going to start with the key feature and then see if I can find it in the polynomials onto the left. So the first one I'm going to look for is a 5th degree polynomial. That means the highest degree is going to be a 5, okay? So with A, I have 3, 2, and 1, so that's not it. B, well, here's my 2 exponents. It's a monomial. I have to add them together. 2 plus 3, that equals 5, okay? So B is a contender here. Exponent of 4, 3, and 9, so my highest was not a 5. Here my degree is 8. This is 5, and that is 7, so that's not what I'm looking for. This has a degree of 5, an exponent of 5, but the degree of this term is polynomial is going to be 7 because 7 was higher. So this is not a 5th degree polynomial. This is actually a 7th degree polynomial. F goes 3, 2, and then nothing, and then 2. Yeah, so it looks like B is going to be our matching for 1. So B and 1 match together. All right, a constant term of -2. Remember, constant means just the number, no variable attached. So look at all of our pieces. We want just the -2 to be part of one of my terms. Don't see it, don't see it. Here it is, look. -2 is just by itself on the end, x squared minus 2. So G and 2 are going to match up. All right, 7th degree polynomial. Oh, we talked about that. Where was it? It was in E, right? My exponents were 5, 3, and 7. So that means the highest was 7. This was a 7th degree polynomial. So E and 3 match together. All right, a leading coefficient of 3. Okay, so leading coefficient means it's in standard form, and that means 3 is the first number. Okay, so standard form also means I have to make sure that my highest degree is first. So A, my highest degree is x cubed. My coefficient here is technically a 1, so that's not it. C, my leading coefficient, has to go with my highest exponent. Highest exponent is 9. That coefficient is 4, so that's not what I'm looking for. We try to trick you by putting this piece first, but that was not the leading coefficient. All right, there's no 3 in there at all. Down here, my highest degree is x cubed, which does have a coefficient of 3. So that means F and 4 get matched. All right, almost there. 4 terms. Okay, that means 4 different pieces with a plus or minus sign connecting them. So A, look at that. 1, 2, 3, 4. 4 pieces. That was nice. So A and 5 go together. Eighth degree polynomial. So my highest degree is going to be an 8. So part C, I have an exponent of 4, 3, and 9. Okay, well, none of those are 8, so it's not C. For D, this piece has a 6 and a 2, so this degree is 8. That's hard to see, isn't it? Let's change that color. I'll do a gold. Okay, so 6 plus 2 gives me 8. My next term, we have 1, 3, and 1, so that degree is 5. Here my degree is 7. 8 is the biggest one, so D and 6 are going to match. And then the last one, we already know what matches, but we're just going to double check it just in case. You never know if you made a mistake early on, so it's always good to check yourself. Equivalent to 4x to the 9th plus 3x to the 4th minus 9x cubed. So what looks like they've done is taken C and written it in standard form, so let's just make sure. So my highest degree is 9, so 4x to the 9th comes first. My next degree was 4, so my next x, it should be 3x to the 4th. And then we end it with my lowest degree of 3, which is negative 9x cubed. So C and 7 are going to match. All right, good job, guys. That was your introduction to polynomials. We are going to do operations with these, like adding, subtracting, multiplying, starting tomorrow. All right, have a great weekend.